Hey, morning, neighbors. If you haven't caught on, my head isn't where a lot of other folks' heads are. But who am I talking about? Space probes. Probes. Any probes. Where do we stick probes? So, Parker Solar Probe. One of the reasons I'm fascinated by what it's going to tell us, and it's still working on it, is one of the detectors inside of that probe is very applicable to Earth information on what particles flow out of the sun, the density and speed and everything else that thing is measured. That Parker Solar Probe in outer space is doing is looking at high energy particles. So on board is a high energy particle detector, and this instrument isn't spoken about very much. It is a relational type measurement we need to get to see how many particles are at the sun and how many particles the Earth sees. What's the ratio of those particles? Change of the volume of those particles due to sunspots or whatever else goes on. Even planetary orbits can affect sunspots to some degree because gravity. So the Parker Solar Probe is detecting particles in, if I understand right, it's a 4 or 5 specific band detector. Now these are related to Geiger counters in their simplicity. So there's relational information between the data, even though that might be looking at subatomic particles from inside what would be an atom if it coalesced, if it formed correctly coming out of the sun. It might be an iron. Um, I think what's emitted from the sun typically is like the first 10 or 15 elements of the periodic table. I mean, there's thousands in there because of isotopes, but the particle emissions from the sun, what physically comes off of that, what ends up is dust on our landscape over tens of millions of years. It's one source is our sun. There's that's just one. How much? It's just interesting. So the reason that detector information just causes me a lot of interest is how the detector works, what it's saying in specific energy bands. When you look back into particle physics, when you look deep into particle physics, the discussion becomes almost purely an energy discussion. And the type of particles and the ratio of those particles. We haven't even begun discussing elements when you're inside the sun. We've changed the rules of physics. Remember, we crossed into an atmosphere that's totally ionizing. Nothing can stay solid in that atmosphere. It's a washing machine of tiny little things. So those discrete measurements were taken in very, very specific wavelengths of particle energies has a deeper meaning to the foundations of life and where we came from. It goes back to studying the universe. The age and the ratios of these particles built off of our sun inform us about the building blocks of the worlds around us. So, a lot going on out there. But really, the goal is to understand what we can do Earth facing. How can we use these marvels of technology and the artificial intelligence we turn loose daily in massive algorithms, predictive algorithms, sorting algorithms, all kinds of software code written by humans, and we know who wrote the software. It's traceability. Um, so those initials. Some folks have initials across time and places you'd never see them. plus 2 IQs. Thanks for listening.